The technology that I chose is voice recognition software. Voice recognition software allows for spoken words to be transferred into actions by a computer, either by translating the voice into text or by carrying out commands. In this case, I will focus on making the voice carry out commands, as it will be required in the invention that I'm working on. Where I'm at with my invention: since being selected as the Edison winner along with my team, we have determined customer/user requirements, performed a prior art search, and now we're in the technology development stage. A voice user interface, or VUI, is what a person interacts with when communicating with a computer or a device. The elements of a VUI include prompts, grammars, and dialogue logic, also referred to as flow. The prompts, or system messages, are all the recordings or synthesized speech played to the user during the dialogue. Grammars define the possible things users can say in response to each prompt. The system can only understand those words, sentences, or phrases that are included within the grammar. The dialogue logic defines the actions taken by the system, for example, responding to what the user has just said. The system then either carries out a command through an action or responds through an audible voice response, such as a chime or a visual cue, such as a light that flashes to let the user know that the command was recognized and successfully processed by the system. For a voice response, the sound is carried out by a voice actor in either a man or a woman's voice, or a synthesized voice that is computer generated. The specific voice chose, the tone and inflection of the voice creates the system's persona. So this is a very important aspect of the creation of the system or the device. For example, you would not want a voice that sounds irritated or hurried. You want a warm, welcoming, and patient voice with proper inflection, if you do choose to use a voice actor. In my opinion, using a voice actor would be much more welcoming than using a synthesized or robotic sounding voice. In the real world, voice user interfaces are not without their challenges. People have almost no patience for a machine that just doesn't understand. Therefore, there is little room for error. Voice user interfaces need to respond to input reliably, or they will be rejected and criticized by their users. Designing a good voice user interface requires interdisciplinary talents of computer science, linguistics, and human factors of psychology, all of which are skills that are expensive and hard to come by. Even with advanced development tools, constructing an effective voice user interface requires an in-depth understanding of both the task to be performed as well as the target audience that will use the system. The closer the voice user interface matches the user's mental model of the task, the easier it will be to use with little or no training for the users, resulting in both higher efficiency and higher user satisfaction. The mental model should be exactly what the user would expect to say to complete the command, without cumbersome extra steps. The design of the voice user interface's dialogue logic should be human-centered, not machine-centered, because it's the human's experience that is most important, because they are the user of the machine, device, or system, and their satisfaction is the most important part. The idea is to build the system around the user, and not to make the user work around the system. Now let's dive deeper into how the technology actually works. To convert speech to on-screen text or a computer command, the system, computer or device, must first transform the sound waves into digital format. This is called signal processing, the signal being the voice. When you speak, you create vibrations in the air, and this is the signal, which gets processed by an analog to digital converter, or ADC, which translates the analog sound waves into digital data that the computer system can understand. To do this, it digitizes the sound by taking precise measurements of the sound wave at frequent intervals in either hundredths or thousandths of a second. The individual parts of the words are broken up into phonemes, which are small segments of sounds that make up words. There are approximately 44 phonemes in English, depending on which research you go by, and in combination, these phonemes create hundreds or thousands of words. The Oxford English Dictionary contains full entries for 171,476 words that are in current use. Given the very large amount of words and phonemes that exist, it's important to limit the number of words in the dictionary if at all possible, as it is in my device that I'm working on for the Edson contest that my team won earlier this year. In my system, the built-in dictionary looks to be able to be reduced to only several hundred words instead of over 100,000 words, making development costs lower while keeping the accuracy high. The phonemes are converted into individual data points, which are then compared to the built-in dictionary of the system. If the data point matches an entry in the built-in dictionary, then the command is carried out. If not, the system indicates to the user that the user must repeat or rephrase the command until it is understood by the system. Current trends in the technology. In the last 20 years, voice recognition technology has come a long way. There have been many advances in technology and increases in computational power at a lower cost, making voice recognition more ubiquitous than it has ever been before. Now let's look at some of the applications of the technology. There are many applications of the voice recognition technology, including cable and satellite set-top boxes, in smartphones such as using Google Search and Siri, in healthcare, and helicopters and high-performance aircraft, and telephony such as automated customer service, automotive speech recognition, for example OnStar and Ford Sync are both advancing this technology and actually using it in vehicles that are in production right now. In court reporting, such as in real-time speech writing, in hands-free computing, speech recognition computer user interfaces use hands-free computing, in home automation, in interactive voice response, in mobile telephony, including mobile email, and multimodal interaction, and pronunciation evaluation, and computer-aided language learning applications, and robotics, and speech-to-text reporter, which is the transcription of speech into text, video captioning, and court reporting, and telematics, for example, vehicle navigation systems, and transcription, such as digital speech-to-text, and also in video games and console systems such as in the Xbox One. Now let's look at the technology-specific development process. In order to develop speech recognition technology, one must create a list of necessary commands to determine the vocabulary size, determine computational power needed, determine the components needed, determine steps in command processing, develop the hardware, and then develop the software. And here's a suggested approach to the focus area, including prerequisites. One should have a deep knowledge in speech recognition software. One should have software development experience and hardware development experience. And one should also have the ability to understand user requirements thoroughly. If one does not have all of these attributes, then they can reach out and have other people join their team that do have these abilities.